Hey there again, y'all. We are on 11.4, so we're going to talk about the circumference and arc length. So a little bit different than what we've been talking about with circles, but a lot in the same as well. So if you remember, the circumference of a circle is the distance around the circle. So before now, we've been talking about the arc length in a degree measure, but now we're going to find the distance. So we're going to use units such as inches, centimeters, feet, millimeters, etc. So that is what we're going to be in now. But we're also going to use the arc length a little later. And remember, the arc length is a portion of the circumference of a circle. So just part of the outer part of the circle is what we're going to use. So looking at the circumference, and many of you might already know this theorem, but theorem 11.8 says the circumference C of a circle is C equals either pi times our diameter, or our circumference equals 2 pi times our radius, where D is the diameter of the circle and R is the radius. So either one of those equations will work. Let's go ahead and finish our theorem. But it just kind of depends on what you're given. And remember, the pi we normally think of as 3.14, but what does that number really mean? Pi is going to tell us the ratio of our circumference compared to our diameter of our circle. So the circumference is 3.14, or approximately 3.14 times bigger than our diameter. So that's really what it's going to tell us. And if you can see this little shaded arrow, the circumference is going to be the whole distance around our circle from start to finish. So again, we are just looking at our circumference for right now. So using one or the other of those equations, we want to find the indicated measure. So if you would like to draw a diagram, you may, but A tells us the circumference of a circle. We want to find the circumference of a circle if the radius is 11 meters. So we want to find C. So looking at these two equations above, it would be the smartest to use the second because we have our radius. So we rewrote our equation. C equals 2 pi r, and that would be a good idea to keep writing just so you can get used to it. So I'm just going to fill in the blank for r. So 2 pi times 11. To keep in pi terms, my answer would be 22 pi. This is going to be the most exact answer. So if it asks you to leave in terms of pi, you need to make sure you can get to that part right there. And then of course we all love to plug it in our calculator. Remember the pi button, if you have a graphing calculator, it's going to be underneath the clear button. On your calculator, it's going to be the second, and I call it the caret. So we will say 22 times pi would be approximately 69.12 meters. Moving on to our next one, the radius. We want to find the radius this time. And the circle with the circumference of 18 yards. So again, if you haven't noticed or before, we normally are going to use this equation the most, just because we are given the radius a lot. So I would always refer back to that one, or of course your diameter will work because the diameter is 2 times the radius. So going back to B, we rewrote our equation. C equals 2 pi r. We're going to fill it in, plug it in, plug it in. 18 equals 2 pi r. And remember, to solve, if I have 18 equals 2 pi r, I want to get r by itself so I can divide by 2 pi. Make sure you are plugging it into your calculator correctly. So your R is 18 over 2 pi. That would be in terms of pi. That's the most exact. And then approximately we can say our radius is 2.86. So if you're having any trouble distinguishing which equation you can use or should use, you can just continue to get through some examples. If you want to stop now and do checkpoint number 1 and then check your answer with mine, that would be a great idea. Moving on to a word problem. So we have a skateboard wheel shown at the right in millimeters. To the nearest meter, how far does the wheel travel when making 35 revolutions? So our step 1, we need to of course find the diameter. So we can just add all of these up because the diameter goes through the center and is from one point of the circle to the other. So they've given us those dimensions. So we'll say 15 plus 2 times 20 because we have 20 millimeters there. So our diameter would be 55 millimeters. Using that information, we can find the circumference, and since we have the diameter, we can use the pi times the diameter. So we'll say pi times 55, which gives us the most exact, but approximately 172.8 millimeters. Our next step, we need to find the distance the wheel travels in 35 revolutions. In one revolution, the wheel travels a distance equal to its circumference, because it's the distance around the circle. In 35 revolutions, the wheel travels a distance equal to 35 times the circumference. So they have actually given you a very useful equation right here that you might want to refer back to if you have any problems, kind of like this. So we are going to take the distance traveled equal to the number of revolutions times our circumference. So our number of revolutions is 35, and we are traveling 107, or our circumference is 172.8 millimeters. So we are at 6,048 millimeters, but now we have to change it into meters. So we will do our conversion. 6,048. 1 meter to 1,000 millimeters will give me 6.048 meters. So the wheel travels about 6 meters in 35 revolutions. So pretty cool how you can tell how many revolutions it takes to get a certain distance. So go ahead and do checkpoint number 2 using that same formula. A little different technique, but you can go ahead and stop and then check your answer. Continuing on with our arc length corollary. So in a circle, the ratio of the lengths of a given arc to the circumference is equal to the ratio of the measures of the arc to 360. So they have given us 2 equations, just broken down a little bit differently. So I've rewrote them. The first one says the arc length of AB, remember length tells us in not degrees right now. So arc length over circumference, remember 2 pi r really gives us our circumference, equals the measure of AB, that will be in degrees, over 360. So I have actually done the same problem over here, if it makes any more sense. Or you can write that same equation as the arc length of AB equals the measure of AB, arc, over 360 times our circumference. So either way you like to write it will be just fine. Using that, let's go down to example 3 using the arc lengths. So A tells us that the arc length, we want to find the arc length of AB. So not the degree, but the measure of arc length compared to our circumference. So if we want to, I've written the equation that we want to use because we're finding the arc length. So the arc length of AB equals 88 degrees over 360, and I remember that because I want my degrees to be together in the same proportion. Equals 2 pi our radius, which they give us as 2, and I would be approximately 3.07 meters. So again, there are a couple ways to go about it, but this seems to be the easiest. Going to the left, kind of looking at another type of problem. Let's do it one more time with that same equation. The measure of the angle, 45 degrees over 360 degrees, or times 2 pi my radius, which is 9. So if I reduce 45 over 136, or 360, I don't know why I just said that, 1/8 times 18 pi. So this is telling me that my arc length is 1/8 of my circumference. So that's kind of what this portion is telling you, pretty much the ratio or the proportion about it. So my answer would be 9 pi over 4, which is approximately 7.07 inches. Alright, going and moving over to B, I want to find the measure, so I'm going to find it in degrees. So I'm going to use my other equation that is written up there. So my arc length would be 38 over 2 pi, my radius is 12.3, equals the measure over 360. I would then cross multiply 360 times 38 over 12.3 times 2 pi to get my measure by itself, and I would get approximately 177 degrees. You guys can go ahead and do 3 and 4 and then check your answers. If you have any questions, please let me know the next time you see me. And last but not least, I just came home from a trip, so I had to check on this conveyor belt. So the luggage on the conveyor belt at the airport is shown at the right. The outer part of the belt is 180 degrees arc at each end. For each outer arc, the radius is 8 feet. Approximate the distance around the belt for a coin on the outer portion round to the nearest foot. So the outer portion is made up of 2 straight sections and 2 semicircles. To find the distance around the outer portion, find the sum of the lengths of each part. So we know that the straight edge is, we have 20 on both sides, so we can automatically find that to be 40 plus 2 times, we know we have a semicircle, so we're going to take half of its circumference, times 2 pi times our radius would give us 8. And we would approximately get 2, or 1/2 times 16 pi, which would go to 8 pi. So we're going to put 40 plus 8 pi to give us approximately 90.27 feet. You can go ahead and do number 5 to check out that same equation, and I think we are done here. So if you have any questions, please feel free to ask, but I hope you enjoyed it, and I hope that you got something out of it. Have a good night.